Welcome to DevOptymize walkthrough. DevOptymize, which is an all-in-one open source DevOps accelerator framework, which is capable of deploy, automate, and scale your application. Here we have DevOptymize GitHub organization, which includes the DevOptymize documentation repo, which gives you a brief overview of what is DevOptymize, how it works, and how you can set up and start your journey with DevOptymize. Here we have the CloudFormation and Terraform repositories, which has pre-built templates for your infrastructure components and blueprints. We also have the Jenkins pipeline repos and child library repos available here, which helps us to automate the entire DevOptimize framework. And finally, you have the DevOptimize KTOps repo, which includes the Argo CD server installation and configuration, and also Argo apps for the cutting edge open source tech stacks you need to ramp up your cluster in a single click. Let's have a look into the DevOptimize documentation repo and understand DevOptimize framework in detail. Let's discover how DevOptimize streamlines your cloud and DevOps journey in just three simple steps. Step 1 is basically the infrastructure build out phase, where we swiftly set up AWS infrastructure with pre-built templates. DevOptimize references blueprints, which ensures a secure, compliant, and scalable foundation. Step 2 is nothing but the DevOptimize platform build out. Here, DevOptimize creates an adaptable DevSecOps platform in our KH cluster, automating zero downtime deployments. DevOptimize open source framework allows full control and rollback capabilities. Step 3 is our monitoring system build out. So here we integrate observability for effective platform monitoring. DevOptimize framework provides reusable code, visually appealing dashboards, and instant alerts. Let's see how to start with DevOptimize. The DevOptimize framework revolves around the Jenkins automation engine and is capable of integrating with any SCM of your choice. Let it be GitHub, GitLab, or Bitbucket, it works seamlessly. To get started with DevOptimize, we have few steps to be followed. The first, we need to create the template repos, which is basically the CloudFormation and Terraform repositories, and fork the Jenkins pipeline repos and child library repos from our GitHub organization. The second step is to is for the users or engineers. They need to update the Git URLs in the installation scripts and run the scripts to install and configure Jenkins. And also post this, the user need to configure the Git and project specific user credentials inside Jenkins. We also need to create a project specific IAM user in our cloud provider. Step 3, uh, we need to run the seed jobs for creating the blueprints and component pipelines. So seed job is nothing but an Jenkins job which helps us to wrap up the DevOptimize framework into the Jenkins automation engine. And the final steps is only like if you are using Terraform as your IAC tool, we do need to run the S3 and DynamoDB pipelines for storing the state file and state log in a centralized location. Let's have a look into the documentation folder. Here we have all the installation and configuration readmes, which we just talked about, creating the child repos, installing and configuring Jenkins using scripts, the DevOptimize building blocks, creating AWS secret pipeline readmes, creating project specific IAM user, creating S3 and DynamoDB pipeline, all those things, including the seed job readmes you can find here. Also, we have a scripts folder where we can find the installation scripts, where you can which can be used to install and configure our Jenkins automation engine. Now let's have a look into the DevOptimize components. The whole framework composed of three parts: master repository, Jenkins automation engine, and the child repository. So the master repository is the main repository that contains the source code of the project, which is basically our IAC code templates from which the Jenkins automation engine would create customized IAC for with the Decide tool, which can be Terraform or CloudFormation. Then we have the Jenkins automation engine. We have primarily come up with a simple automation engine by using Jenkins as UI to receive input from the engineers who would be using the framework. Backend of the engine is our custom created scripts and pipelines, which is the core of our framework. Child repository is a repository that is created by our Jenkins automation engine by collaborating the templates in the master repository and values given as input by engineers to the Jenkins. Basically, it means that the templates is in the master repository will be modified by our Jenkins automation engine based on the user input and kept in a separate repo, which would be the IAC repo for our project going forward. To note here is Jenkins automation engine only creates the content in our repository, not the repository. So the repository would be basically created by ourselves. So here you can find the detailed workflow diagram of how DevOptimize IAC automation engine works. We can find the Jenkins automation engine, the Terraform and CloudFormation workflows, the master repository details, the entire stage details of how uh, the workflow goes. Let it be Terraform create, modify, or destroy. We have separate workflow for this. And at the end, we create our infrastructure in AWS. So the same goes for CFT also. We have a create and a delete workflow. Let's have a look into our KATOPS uh, framework. So this is the DevOptimize KATOPS repository. In this repo, you can find the installation and configuration scripts and YAML files and manifest files, Helm charts for bootstrapping our cluster. Let's look into what is DevOptimize KATOPS. DevOptimize KATOPS automates the bootstrapping of our KH cluster in a single click. Here we have Argo CD as our control engine. We have an inception.sh shell script in place which installs and configures the Argo CD for us. We also have Argo apps which helps in auto deployment of open source DevSecOps and monitoring components into our cluster, thus making the cluster secure and robust. Here's the workflow diagram of how KATOPS framework works. Let's have a walkthrough through it. So the first is the inception.sh where the user inputs the parameters based on the Kubernetes cluster which we have. So the DevOptimize KATOPS works in an assumption that we have an AWS account and an EKS cluster and other infras like IAM roles and S3 bucket, which comes as a prerequisites for the toolset which we are deploying are already in place. So let's have a look into the framework. So here we have the inception.sh, which has two steps. The first one is the kickstart. Basically, we call it as kickstart. So here the inception script deploys the kickstart components, mainly our Argo CD, and also it integrates with our KATOPS repo. The second is the tech stack deployment. So once Argo CD is deployed and configured, then we need to deploy the tech stack components into our Kubernetes cluster. So the tech stack components are uh, basically like three. The first one is the add-on stack, where we deploy all the add-ons or generic components which are needed for our workloads to run, which includes Valero for cluster backups, AWS load balancer controller, secret store driver, Nginx encryption controller, Carpenter, metric server, not permission handler, EBS CSI driver, EFS CSI driver, and all. Then we have the observability and monitoring stack, where we have focused on the LGMT stack, which comes as like Loki, Grafana, Mimir, and Tempo. Then we have the SecOps stacks where we install the security tools, open source tools like Istio, Kyverno, SonarCube, Trivia Operator, and Falco. The inception.sh helps us to bootstrap our cluster in a single click.